In this video we're going to look at how to differentiate single term functions. Now, I'm not going to go too much into what differentiation is and why it works, but when we have single terms we can use this formula to differentiate. So if we've got something written in function form, so if f of x is equal to x to the power of n, then f dash x, which is how we record the derived function of x, is equal to n of x to the n minus 1. And in practice this is incredibly easy to do. So in this first example I'm told that a function of x is x to the power of 4. So the derived function, so f dash x, I'm just going to apply that formula at the top, so I'm going to move the 4 to the front and reduce the power by 1. And this is the gradient function of the function above. Second example then, I can't initially use the formula because I don't have this written in index form. So I know that root x is the same as x to the power of a half. So I'm going to rewrite it like that. And then I can apply the formula as before. So I'll move to the half to the front. And I'll reduce the power by a half as well to give me negative a half. In this third example then, again this is not written in index form, but I do know that a reciprocal will give me a negative power, and I do know that root x becomes x to the half. So I'm going to write this as 1 over x to the half, and then I'm going to write that in index form, so it becomes x to the negative half. And now I can differentiate. So f dash x is equal to, move the negative a half to the front, x reduced the power by 1, so that's negative 3 over 2. And then this final example, it's already in index form, so that's fine. Now I have a 2 in the front. Now all I have to do with that 2 pretty much is ignore it. I don't actually have to do anything with it with the differentiation. So f dash x, so I move the power to the front, so I've now got 3 lots of 2x, and then I reduce the power by 1, 2, and then 3 lots of 2 can simplify to 6, so I get 6x squared.